So I'm Beth Hemmings here with Vita student at Bluedot Festival, and joining me is Suzie Imber, Professor of Planetary Science at the University of Leicester and also the winner of the BBC's Astronaut Have You Got What It Takes? So Suzie, as a university professor, could you tell us how students can begin big?
I think my advice to students would be to do lots of things outside their normal academic study. So I really want my physics students to study physics as often as they can, as much as they can, but also think about the other things that they have got to do at university. They can join clubs and societies and have hobbies, because I think actually balance is really important in life, and I think hobbies and other things give you some balance along with your academic studies. So might not be the conventional answer, but I would say take up other things and do other things.
That's great advice. So you think it's important to, get used to having that balance in life, because that's what life's all about, balancing things.
Yeah, and I think you can get too caught up on exams and the next exam you have to take, and it adds to your stress levels, and I think that you need to see the bigger picture, and I think it's hard before you do a study. So that's what I say to my students anyway.
So who or what inspired you to pursue a career in planetary science?
I think I was really inspired to be a planetary scientist when I did some work experience at NASA. Yeah, it was amazing. I went there when I was an undergrad for a couple of summers to be an intern. Yeah, and I think that totally changed my perspective about science. I was working on kind of cutting edge science. Even though I wasn't a very good scientist, I was just starting out, they gave me opportunities to discover new things alongside the scientists that work there, and that really inspired me, I think.
Yeah. So what was the most inspiring and mind-blowing thing that you saw? If it's not confidential, are you allowed to tell us? Maybe at NASA?
Yeah, well, nothing's confidential, I can tell you, but it's hard to pin it down to one particular thing, and if I did, I think it'd be a little bit too specific, so I don't think people would find it very interesting. But we discovered a new phenomena, basically. We looked at magnetic field data every day for weeks, and then discovered something new about that magnetic field of the Earth. So
what did you discover?
We discovered a structure, and we tried to understand how the structure evolved and changed with time, and where it formed and why it was important. Yeah.
So cool. Oh my God. So as a woman, have you ever faced any challenges working in a primarily male-dominated industry?
No, I don't think I have, actually, and I know that there's lots of other female scientists who would give you a different answer to that, and I totally respect their experiences, but my experience hasn't been negative at all, I don't think. I've had a really positive experience. My colleagues are all really supportive, and they don't treat me any differently, and that's the best that you can hope for, I think. Yeah.
So significantly nowadays, more men are sort of choosing to take a role into science, more so than women. So do you think we need to be trying to get more women interested in science at more of a younger age, maybe like primary school age?
Absolutely, I do, and I think as a scientist we all have a responsibility to do exactly that. So after I won Astronauts, I felt like I had a platform to speak to people. Before that I was just sitting in my office doing my thing, and then I was on television, and then people begin to invite you to go and talk to people, and I've spoken to 25,000 children since October, over the last 8 months, about being a scientist, about how much I love my job, and trying to show them that, especially for the young girls in the audience, I'm not talking about women in science. I'm just being one in front of them, and I'm showing them, I look a bit like them, they could be me, and so maybe if they just see a role model that has made this journey, they believe they can as well, and a lot of it is about self-belief. So yeah, I think we all have a responsibility, and actually I think young children, I think is particularly important. It's really easy to write off the 6-year-olds, but we shouldn't. Because age 6 or 7, they decide they don't want to be scientists anymore, and then it's too late. So I think we should go and find primary school children and show them that a career as a scientist is a really incredible thing, and get them interested at a young age.
And then it's actually really cool.
Yeah. Exactly. It's a really amazing career and job, and it's fundamentally interesting. And I hate the idea that when they reach 7, they decide that science isn't for them. They haven't done any science by that point, and they've already made that decision. So we have to get in there early, I think.
So when you've been speaking to 25,000 children, did you get to have maybe a little Q&A at the end? Was there any children that maybe approached you and was like, you've really inspired me, I actually want to pursue this?
Yeah, so normally with the little ones, we do a Q&A, and they ask all about kind of astronaut training, and that's really easy hook to capture them on the idea that they could go into space one day. The older ones, I talk more about planetary science as well as about astronauts, and they're the ones that kind of say, I wasn't sure I wanted to be a scientist, but now I see, what you have to do to get there, and so that's really rewarding for me to think that I've kind of touched some of them and moved them in that direction.
Inspired someone.
I know, that's what I set out to do at the end of Astronauts. I didn't set out to talk to 25,000 kids, I set out to replace myself in the scientific community, and I thought if I can inspire a few, then I've done my job. So it's just kind of snowballed from there. Yeah.
So what's the most inspiring moment, or maybe the most unexpected moment that you faced in your career?
Unexpected good or unexpected bad? Unexpected good.
Oh, maybe both. Bad first.
I think, well, I know one of your questions was about challenges, so I'm going to talk about kind of challenges and when I think your question was something like, what's the biggest challenge you face in your career? And that's a really easy one for me, actually, because I had a paralytic fear of public speaking.
Yeah. You did perfectly well today. You'd never know.
Right, and so I couldn't stand up and speak in front of 5 people. My first ever science presentation, they gave me a laser pointer and I had some slides. I was talking for 12 minutes in front of about 10 people, and my hands were shaking so much I couldn't point at the slides. This laser pointer was flying all over the screen, and I was terrified. And that's been a massive deal for me, actually. I realised quite early on that that's going to be a really big problem for me, because in science we do a lot of presentations, and so over the last 10 years I've just worked at that, and then a few weeks ago I went on stage at the Royal Albert Hall and there were 5,000 people, and it felt like, maybe it's not a big deal for most people, but for me, having made that massive journey, it was kind of the end of that journey where I felt like I'd finally completed that. Yeah, like, okay, I'm all right. Yeah, I can do it. And I don't get so nervous anymore, and it's much easier, but it has been a really long journey. And I think often people only see, the me that stands up on the stage now and doesn't look nervous, and they would never know that, I felt like they do 10 years ago, and it's a long journey. So
maybe you should put that in your talks as well. Like, you never guess what? I never used to be able to do this.
Sometimes I do, yeah, depending on who I'm talking to. Yeah, it's all about kind of overcoming whatever your fear is, and maybe they're brilliant public speakers, but they're afraid of something else, and it's all about facing it and working on it, I think.
It's just creating awareness about things, isn't it? Because a lot of people deal with that issue of like not being able to speak in front of crowds. It's very, very common.
Yeah, and actually you see these people, they all seem perfect, and you never see the backstory of the things they had to overcome. So I think it's quite important, actually. Yeah, that's it.
Brilliant. So space weather is regarded as a risk to our societal technology by the government. So has any recent research that you found, any changes that have happened recently that we should be worried about?
There are some really interesting things happening in space weather, actually. So, yeah, I'm not
enlighten us.
Science lecture, but so the sun has this 11-year activity cycle. So it gets more active and less active. And once every 11 years, the magnetic fields of the sun, the poles flip, like they do at the Earth once every however long. And it's kind of chaotic at the Earth, and it's hard to understand. At the sun, it does it every approximately 11 years. And we've had a really active sun for hundreds of years. And then about 10 years ago, the sun went into its minimum, as it always does, and the activity stayed low, and it took ages to pick up again. And then we had, in the solar cycle, that was really low in amplitude. And so now we're wondering whether we've come to the end of an era with the sun. It's been active for hundreds of years. Now it's less active, and no one knows what's going to happen in the future. And so it's added a lot of uncertainty into something that we could rely upon, which is that the sun is active and it does this 11-year cycle, and now it doesn't anymore. And so that's exciting for us. We don't understand the influence of the sun on the Earth. That's one of the things we're working on, and now even the sun is changing. That's kind of exciting for a scientist to work on and think about. And we're launching missions continually out into the solar system. So space science is always evolving and changing as we launch more missions, and every few years a big mission gets launched and we discover new things undoubtedly about the system. So whether it's our mission going to Mercury in a few months' time, or whether it's Juno that's now at Jupiter, or Cassini spent 12 years at Saturn, or the missions around the Earth, we're totally evolving our science continually, and that's why it's so exciting. I know.
Mind blown. So could you tell us a little bit more about your Mercury trip?
Yeah. Well, I'm not going to make not personally my Mercury trip, but yeah, this is an amazing mission. It is the first ever 2 spacecraft mission to go to another planet. To start with, so it's ambitious. The 2 spacecraft travel together. One was built by the European Space Agency and one by the Japanese Space Agency, and they travel together to Mercury. It takes 7 years to get there, and when they get there they split apart and they orbit the planet separately. And so yeah, it's a really ambitious mission. Yeah, 2 different locations at once. It's really important for space weather to see what's coming from the sun and what the influence is on the planet, and you need 2 measurements to do that. So it's like cause and effect, basically. And then we've built one of the instruments on board. And so yeah, so this is amazing. In our lab, in our clean rooms at the University of Leicester, we've built an instrument that's going to Mercury, and it's taken 15 years. And it's complete, and now it's in French Guiana with the whole spacecraft ready to launch in October, so in 4 months' time. So it's been a massive journey for us over a really long time period. But it's about to launch, and we're massively excited. So yeah.
So in the next couple of years, we'll just be analysing. Well, it takes 7 years to get there.
It takes 7 years to get there, and actually our instrument won't be switched on for those 7 years, or we won't be taking data for those 7 years. It'll be on, and we'll be checking it. But we've got lots to do in the meantime. It's not like we'll be sitting around. Yeah, no, we've got lots of work to do on our instrument. We've got an exact replica in the lab and we'll be testing it to try and see what kind of things it can detect and what it would mean if it did detect a different signal. So there's lots of work to do. But 2025 is when we arrive and turn on the instruments, and that's going to be another really pivotal moment in our careers, essentially. So, yeah.
Is there anything that you're expecting to find? Is there any predictions that you've made so far, or just see what happens?
I mean, Mercury is such a strange place. Like, the last mission that went there, the only mission that's orbited the planet, was a NASA mission in 2011. It arrived and was there for 4 years, called Messenger, and it had a similar instrument to ours, but it had very poor resolution and very low energy range, or a limited energy range, and so it was looking for what the surface is made of, and its measurements were quite limited. Our instrument has a much better resolution, much better energy range, so we're going to be able to detect substances that the last one couldn't detect. And there's this mysterious black substance, low reflectivity material on the surface of Mercury that's probably quite fundamental to Mercury's dynamics, and no one knows what it is. And our instrument might be able to tell us what that stuff is. We know it's an organic material, we don't know anything else about it, so that's just one thing that we're hoping to find out when we get there.
Wow. Yeah. So why Mercury over all the other planets?
So we do go to all the planets, but Mercury is a really special planet because I'm thinking about space weather in general, and I want to understand the physics of how the sun interacts with the planetary magnetic field. That's pretty fundamental to space weather. So at the Earth, we've got a field that's quite strong. We're quite far from the sun relative to Mercury, so big events happen quite rarely. Mercury has a weak field. It's very close to the sun, so it experiences the worst ever space weather event at the Earth every day. So that's why I really want to work with Mercury, because I want to understand the physics, and by seeing an event every day or multiple times a day, I can really understand that physics, because I have lots of observations and then I can apply that to the Earth. So that's one reason to go to Mercury.
That's a great reason.
Yeah.
So what do you think will be the next scientific breakthrough in our audience's lifetime?
Space. Let's go with space. Gosh, that's a really good question. We're working on so many things right now. So we're working on microsatellites, so tiny satellites the size of a Coke can, launching into space with instruments on them. The idea is that we launch constellations of these things, and it forms like a mesh of data from which we can really interpret the physics of what's happening. I think they are the future, actually, in terms of Earth observation science, so swarms of constellations of microsatellites, basically, and we're working on that technology all the time. I think that we are going to send, from a human spaceflight perspective, we're going to send people to the moon. We're going to build something called a deep space gateway, which is like a space station that orbits the moon, and from there be able to go to Mars. And so that's a pretty big step for humans as a whole. I don't think it's going to happen tomorrow, and then there's this other element, which is the element of the commercial spaceflight industry. So the idea being that you're going to have companies that take people, space tourism, take people into space. Yeah, go on in space. And this idea of people in space has been the preserve of the government in the past, NASA and ESA and other space agencies. And now it's going to be open to commercial industry to go and do that. And that really is going to revolutionize things. It's pushing technology onwards. It's changing the game, really. And there's a place for both NASA and ESA and the others and commercial spaceflight. They go hand in hand. And then there's one more thing. So many things I want to tell you about. This is exoplanets. So the idea that we're now finding planets around other stars elsewhere in the universe. And now we're being able to characterize what those planets look like and find Earth-like planets orbiting stars. And so all of these things, in the last few years, our knowledge has really opened up, and I think it's a pretty exciting time to work in this area. So, yeah.
So excited. I wish I could just talk to you all day. So let's talk a little bit about the BBC show.
Yeah.
So you won the BBC's Astronauts. Have you got what it takes?
Yep.
So the prize was being a letter of recommendation from the real astronaut, Chad Hadfield. Chris Hadfield. So you said during your talk earlier that you learned a lot about yourself during that process. What do you think was the most, maybe shocking revelation that you made about yourself during that process?
I think that all the way through, I figured that I was going to be the next one to go, and I figured I'd be the first one out, and then every week I was thinking, it's going to be me this time. I just totally figured that I wouldn't last very long, and so I was really surprised to be in it all the way to the end. So I learned a lot about kind of how critical I am of myself. I was watching everyone else and thinking I was failing and they were all doing really well. And by watching the footage, I realized that we were all doing the same. And so I sort of need to reevaluate how critical I am of what I'm doing. But also I made a ton of stupid mistakes that I need to think about. So So
What was the worst mistake you made?
oh, I got in Stevenage. I got the Mars rover stuck in a cave forever in a simulation of driving a Mars rover on Mars. But I spoke to Tim Peake a couple of days ago, and he told me that he also got that Mars rover stuck, and so now I don't feel so bad because Tim Peake did it too. But actually, at the end of the show. At the end, we went for a beer with Chris Hadfield, which is amazing. And he said, rather than saying well done, he said, you know what, you're abysmal at operating complex machinery. And I thought, okay, thanks. But actually, he's totally right. And so I now need to think about, what can I do to try and improve those skills? Because I just haven't been in an environment, I don't fly planes for a living, I haven't been in an environment where I'm doing that kind of thing, and I need to just work on that, and I think it's possible. So lots of tips from him, yeah.
So in your talk as well, you said that with this letter of recommendation, if they did our applications again, that you definitely apply. What would like your reaction be, I suppose, if you got through, you got to go to space as an astronaut? Like, it's pretty mind blowing, wouldn't it?
I don't want to get too excited though, because there's a massive selection process that you have to go through to get there, and the probability is that I wouldn't make it. But I, as a scientist and an explorer, it's kind of a dream to be an astronaut. It's both of those things together. And I think going on the show almost made me more enthusiastic about being an astronaut than I was before, because I learned more about what they do in space and what the environment is like. And it just gave me kind of a taste of the training. And so, yeah, so I would love to. I would still love to do it, but we've got to wait. We've got to wait and see.
We'll have to wait and see. So you also go on a lot of expeditions up huge mountains sides that other people just wouldn't even dare to do. So what was maybe the most impactful piece of data that you collected on one of these expeditions that's helped you really well in your work, like an advancement?
There's a few things that we did. We collected samples and sent them back to the lab of bacteria looking for a cure to bacterial resistance, basically. So, antibodies, antibodies, that's not the right word. Yeah. What's the word? What am I looking for? What do you take when you're sick? Antibiotics. That's it. See, my brain isn't functioning. Antibiotics are becoming resistant. And so what we are trying to do is bring in different types of bacteria from really remote places where they haven't come into contact with humans before, to try to see whether we can use these bacteria to try to make different types of antibiotic. And I don't know whether our samples will have come to anything, but we're going to keep taking samples, keep sending them in, and that's a real fundamental change to society if we find something new. So that would be pretty great. Yeah.
Science changing lives.
Yeah.